Good morning, developers. If you are new to the channel, my name is Rob, and it is JavaScript Tuesday. Tuesday is the day that we look at the language itself. How does JavaScript work? No libraries, no projects, nothing like that. Just how does it work? And we've been going through the ECMAScript updates. And we'll get over to our code editor here in a second and take a look at it. But today we arrive at BigInt. BigInt came out in ECMAScript 2020 or ES11, whichever you prefer. And I'll drop a couple links in the description that will have to do with the relationship between those two if you want, or the other videos I've got in the playlist. But I just did another video on why this was necessary. So I'm not going to go into too much detail, but the really short version, there's a standard called IEEE 754. Okay, and you probably don't know what that is, but it defines the standard for how computers are supposed to store decimals. And the reason for that is because computers have a really hard time storing fractional numbers in binary. How so? Well, as a quick for instance, the number 0.1 is really easy for us to write in the normal number system. It's not easy for a computer to write in binary. What's an example? Well, take for example the number 1/3. That is 0.3333 and keep on going. Right? You can never be completely precise writing the number 1/3. The number 0.1 is the same in binary, where it doesn't matter how many places you have, you can't ever be totally precise. So IEEE 754 determined, okay, we've got 64 bits to work with. 52 of them are going to be dedicated to storing the actual number in binary. Okay, so this is a decimal place. Pretty much all programming languages use it. Not all do, but for double precision float, that's how it works. And you're saying, wait a minute, Rob, we're talking about integers. Why do we need BigInt if this is a decimal thing? Well, because how many different data types are there for numbers before BigInt in JavaScript? There's just this one. There's only number. In Python, as a for instance, it has int and float. Like those are distinct data types. So float does things the same way as JavaScript does with its floats. The difference is it has its own int, and it can be arbitrarily big. It's not limited to that 52. Because JavaScript only has one data type, ints have the same limitations that floats do, which means the biggest number that we can precisely represent in JavaScript, we'll do it over here, is 2 to the 53rd power minus 1. That is, if you took all 52 spots and put a 1 in every single slot, that's the number you'd come up with. It's just over 9 quadrillion, right? Which is a huge number, but it isn't big enough anymore. So we need this. And I'll tell you up front that as we're just about to go look at the docs here, the main thing that you need to remember is that BigInt is going to be potentially confusing, not because it's a difficult concept to understand. Right? We need bigger numbers than this, so we can't use this anymore. We need to use this. The problem is a new data type is a big deal, not just because you need to learn how it works, but because it has to interact with the entire language. We don't want to break JavaScript with this new thing. As for instance, what if we have an array full of numbers and big ints and you run sort? How's it supposed to work? Or what if you try and cast a string, a big int into a string, or you try and concatenate a string into a big int? What happens? There's a whole bunch of gotchas, and I will take you through some of them, not all of them, but just try and equip you and prepare you so that when you use it, if you run into weirdness, you'll know where to look and how to find it. But just there's a hidden gem in the docs that is kind of down the page a ways. Do not use this unless you have reason to think that your number might be bigger than this or negative bigger than this. Okay, let's hop over to the docs. I'm over to the MDN docs. We got BigInt open here, and we're going to spend quite a bit of time here. We'll hop back and forth between the code editor, but we're not going to be able to cover everything because the video is just simply too long and there's too many just odd cases. Just want to show you where everything's at, so when you use it and something weird happens, you know where to go. As I mentioned already, this part is easy enough to understand. BigInts, it represents numeric values which are simply too big for the number primitive. You need something bigger than 2 to the 53rd power minus 1. BigInt is what you are after. And it shows that we can create it by appending the letter n to the end of an integer literal, meaning just a number. Or you can call the BigInt function. It's not a constructor, so we don't use the word new. It's a function. And then we give it an integer value or a string value. And so real quick,
This is the syntax. We'll hop over in just a second. But a number with the letter n at the end has designated this as a big int. It's not a number. You can pass a number to the big int function. These two are exactly the same. You just don't have the goofy n there. The rest of these are strings. So you can pass a string, which in this case is an integer. It just happens to have quotes around it. You can pass it a hex, you can pass it an octal, or you can pass it a binary number. And in all cases, they've used the same number, but it will always come out like that. So let's hop over to code editor. I'm using VS Code. Use anything you want. I've got an HTML file with script tags. If you want to use Node.js, that's fine. It's active as of 10.4, so you should be good. If we make a variable here called bignum.js, and we'll set that equal to 2 to the 53rd power minus 1. So that's that ridiculous number that they were telling us is the top. If we take that, I'm gonna comment. Actually, let's drop it on the next line here, and we'll add the number 2 to it. Come back over to the browser and refresh our file here. That's the biggest number, and that's the same number plus 2, which obviously it's wrong. So you can play with this as much as you want, but it suffers from the problem we already talked about, where we have simply that odd precision issue that we're going to have to deal with. If we do bignum bi for big int, let's take bignum.js and let's pass it to our function. So big int, it's proper case, so big int proper case, and we hand that to it, and we console.log that thing. And then right below it, we'll do the same thing, but we'll do plus 2n. Make note of that because we're going to talk about that here in just a second. We refresh it. First of all, one nice thing that Chrome did, at least I think, the integers for my theme at least are purple. Big ints are kind of a grayish color. I'm not sure what you'd call that. And they have the letter n at the end to denote, hey, this is a different data type. And for that second one there, it is the correct answer. It did actually add 2 to that number. Why did I put 2 there? Well, let me remove the n and just go straight to 2 and refresh it, and we get the first of probably many errors in your life with big int. Why did this happen? Well, if we come back over here, they're similar to numbers but differ. Okay, big ints can't be used with the built-in math object. We'll look at that in a second, and cannot be mixed with a number value in operations. Even though up here, a number and a big int are the same, a big int can just get bigger. They're totally disparate data types to JavaScript. You can't take a string and divide it by an array. That makes no sense. You can't take an object and add a boolean to it. That also makes no sense. Just like that, you can't take a big int and add the number 2 to it. They are different data types. And maybe eventually that'll be reconciled, though I doubt it. As I said, there's so much going on from 30 years of JavaScript history. You can't just drop in a new data type and change the whole language, you know, in the ideal way. You'd need to start from the ground up, which of course we cannot do. They have to be coerced or cast to the same type in order to work together. So it mentions one last time here, be careful going back and forth between big int and number, because if you go too high and you cast it to a number, you're gonna lose that precision. Okay, we're going to skip over a few of these things here. The type of, if you do type of, there's literally a new type called big int. The operators, though, is what we're interested in. Most operators support big ints, and they're all right here. Plus, minus, times, divided, modulus, and then the exponent, which you've already seen. It does the binary stuff too, so if you want to move bits around, you can. You can make something negative. You can also do a plus plus and a minus minus on big ints. That is just fine. You just can't do any of these arithmetic operators on a big int mixed with a number. That is not okay. We contrast that with right here. You can do comparison stuff. So like greater than, less than, you can mix them there because that's simply going to return true or false. It doesn't matter why, at least at the moment. But if we come over here again, you saw line 9, that breaks. I'll copy this and comment it out. Cannot mix data types. If we put right below it here to end, that will work, which we've already talked about. If you want to check to see big num bi, so this is the big int version. If we want to check to see if that equals, or rather is greater than bignum.js and save it, we won't get our error here. It's false because they happen to be equal. And we'll get to this here in a second, but if I change this to a double equals and refresh, we get true. Exactly what you should expect. If I do a triple equals, this is going to be false because they're different data types. Just like you would expect the number 3 like this, that is going to be fine. That is not going to be fine because they're different data types. So exactly the same thing is going to be true here. False, different data types. Okay? If we hop back over to the docs, again, all of the relational operators will work just fine. The unary plus will not work. So you may not even be aware of this, but if you stick a plus at the beginning of a number, it will convert it into a number. And I'll do this one here just in the console. If we make a variable literally called 3 and we set it equal to the string 3, if I do plus 3, you can see down below there, it converted it to the number. You cannot do that, so we'll do const 2 equals 2n. We can't do plus 2 because it's going to break. It's trying to convert it to a number in a weird way. And if you want to know why, it would break asm.js. Not going to go into why. asm.js allows you to use programming languages like C in the browser. Maybe this will eventually get caught up. Don't know, but you can check that out. Unsigned right shift, you'll know if you need that. That means you're shifting bits. You would never need that because all big ints are already signed, so you'd never have an unsigned big int because they're all signed. Okay, a couple of special cases. If you use the addition symbol, you're really using the concatenate symbol between big int and string. It's the same with a number. If you take the string, if you take the number 3 and do plus string, you really are concatenating. You're not adding. Division is simply truncating. You cannot represent a decimal in a big int. That's the whole point here. So if you try and divide 2 big ints, you're just going to get whatever the integer is without the decimal behind it. Okay? They give some examples here. Comparisons, we already talked about that. There's false and true based on the double or the triple equal sign. You can compare them like we already saw as well. These work exactly like you expect. This is one to make note of here before we kind of wrap up. If you have an array that has both data types in it, meaning numbers and big ints, it is not going to know how to handle that. So if we do const mixed, I think is the variable name they used, if we do 1 and then 6n and then -9 and then 10,000 n or 1,000 n, I guess, I'm just going to put some more stuff in here. Okay, if we run mixed.sort, open close, and then we constant.log mixed, remember mixed, it changes the array in place. It's going to be the sorted version of our array. If we come over and refresh, you can see it did not do what we might have hoped it would because they're different data types. That just doesn't make sense. So if you want to sort, use your own function. Don't be trying to subtract because that's not going to make any sense, or you're going to have to cast them, which is bad because you'll lose precision. Instead, we'll do what they've got here. We take mixed sort, and we're going to return. Let me drop this down. If A is less than B, that's fine. Doesn't matter whether they're mixed data types. If A is less than B, then return -1. Otherwise, if A is greater than B, then return 1. Otherwise, return 0. This function will work just fine. We need to console it first here, line 22. Now if we refresh, it will come out the way that it should. They will be in the correct order because the comparison part works, the subtraction and the default sort behavior does not. Okay? Passing over the object stuff, we're not worried about that. 0n is false, just like 0 is false. Everything else is true. Cryptography, you can read that if you want to. With JSON, you cannot stringify out of the box. They give an example here of how you can set up your own prototype, which is really useful. Everything has a to.json prototype that you can override, and then it will work. I keep going down a little bit farther here. There are some notes on specifics. If you're going to coerce it or you're going to cast it into a different data type, this is how it will all work. And most of the time it's going to be really obvious. It's going to be the behavior that you would expect. It's just something to be aware of. Keep going down here. There are a few static methods. These have to do with bits. So as int n has to do with working with signed integers. So if you're moving bits around, and the example down here, it can be kind of fun. Like this is 25n in binary. You can move it, move the number of bits over. If you want to do the same thing but as an unsigned integer, it's right there. Pass over the properties. The methods, really the only thing that's interesting here is that you can convert it to a string with the toString method, or you can use functional programming to get the value of. And that is pretty much everything we need to cover on it in this video. Keep looking through the docs if you're looking for particular use cases, because it's all there. If you've got questions or comments, please post them. As kind of a fun send-off, problem number 20 for Project Euler is something that you cannot do in JavaScript, at least without some serious math, but you can do in Python. Find the sum of the digits in the number 100 factorial. Well, if we hop over, I have a file here called 100fact.py. If Python, all it has to do, it has a factorial function. You pass the number 100 to it. We store it in the variable x, and Python has no limits. It never has. Print off line 5. If we run that, this ridiculous thing is the integer that's using much more than 52 bits, or I should say is bigger than 9 quadrillion. There's the answer of summing the digits together. Well, JavaScript is out of luck, except it's not anymore. We will make a variable called 100fact, and we'll set that to 1n. This is actually a really good way to show you how to interact with it, because a lot of the stuff that we passed over or we mentioned, we will use here. There is no way that I know of in JavaScript to do 100 factorial out of the box, so we'll just do it the old-fashioned way. We're gonna set I equal to 100n. While I is bigger than 0, we can commingle here because this is a comparison. You can use 0n, but you don't have to. And remember, we can decrement and increment. So minus minus or plus plus both work. So we'll take 100fact and we will times equal I. And when we are done, if we console.log 100fact, JavaScript has joined the party. It can represent this absurd number and solve our algorithm. And let's go ahead and finish it. Like I said, we can do another thing here that will be useful. Sum equals 0. We will loop through. So for, we're going to do let care of grab 100fact, and we're going to cast it into a string, open close like that. And we're going to do sum plus equals. It will be the parse int, so we'll have to go back to an integer of character. If you want, you could do a big int here as well. It makes no difference. Well, no, it does. We have to put 0n up there, so let's stick with that. So we're converting this thing into a string so that we can grab individual characters. Now we're going back to a big int for each one and adding it to our sum. And if at the bottom here we console.log sum, we should get this number 648. And we do. So JavaScript can knock out Project Euler number 20, do big integers, no problem. Keep looking through the docs if you've got questions. Everything is here. I will link the video that I mentioned where I go over in detail why this was necessary, the binary fractions, all of that stuff, if you would like to watch it. Otherwise, I will see you in the next one. Thanks for watching.